Hello everybody and welcome to the final part of this series where I teach you the CLL method on 2x2. So in today's video we're going to look at the last two subsets of this method, which will totally comprise 12 algorithms, 6 in each, and these are the Sune and the Anti-Sune cases. So these are known to be the most notorious, if not the most difficult cases for CLL, like when you're learning CLL, just because they're so tough to recognize and when you first learn them, and they look so similar. So yeah, let's get right into this one, starting with the Sune cases. So as usual, the Sune cases are, so you would know from 3x3 that this is the algorithm for a Sune. It's called SUNE, Sune. It might be pronounced differently, but that's how I pronounce it. And so here, the way you solve this is R, U, R prime, U, R, U, 2, R prime. So just telling you guys that. So for the 2x2, the way you recognize this is one corner will be solved, like oriented on top, and the other three are like this. So the other three, one is adjacent to it on the right, and then they just moved in an anti-clockwise sense. So, you can see the similarity with the 3x3 here. So again, on 3x3, the algorithm is the same, and it's a beginner's method algorithm. So yeah, let's get right into this with the first case. This is the first case, and for all the Sune cases, the way we recognize them is by looking at 4 stickers, these two and these two. That's why it's tough, because you have to look at these stickers, they're very far away. So these 4 stickers are what we'll look at. So this is a normal Sune, and the way you recognize this is these two are opposite and these two are opposite. And the way you execute it is from this angle, you do R, U, R prime, U, R, U2, R prime. So again, it's a Sune case with this corner here and these 3 here. You have opposite colors here as well as here. So R, U, R prime, U, R, U2, R prime. So that's the first case. Moving on to the second one. So this is the second Sune case, and as you can see, it's a Sune case. Very easy to see that it's a Sune case, but not easy to recognize. So here we have opposite colors here, but these two colors are the same. They're not opposite as in the previous case. So that's the way you recognize it, by seeing the opposite colors here, green and blue, but these are the same orange. The way you execute this is you put it in the back. So you do U2 to put it in the back, and you do this algorithm. R, U, R prime, U, R prime, F, R, F prime, R, U2, R prime. So again, opposite colors, same colors, put it in the back with U2, R, U, R prime, U, followed by a sledgehammer, R prime, F, R, F prime, and then R, U2, R prime. So that's the second case. Moving on to the third one. So this is the third case, and here we have these two as opposite colors. So this is a sort of an easier case where you only need to see these two colors, and the fact that they are opposite is enough to recognize this case. So these two are opposite colors and these two are just random colors, right? So obviously if these two are also opposite colors, it becomes the first case, but here this is like a derivative of that case where these two are opposite and these two are random, and this is widely known as the Nicholas case in cubing. And the algorithm to do it is, so you could do it with R and L moves, R, U and L moves, but the way to do it with only R moves is pretty simple. So you do R, U prime, R prime, F, R prime, F prime, R. So it's the same as doing R, U prime, L prime, U, R prime, U prime, L, but without the L moves. So R, U prime, R prime, F, R prime, F prime, R. Quite simple. So moving on to the fourth case. So this is the fourth case, and here again these two are just random colors, but these two are the same color. So in the previous case, which was Nicholas, these two are opposite colors, but now they're the same color. That's the way you recognize it, and the way you execute it is by holding it from this angle and doing this algorithm. F, R prime, F prime, R, so a head slammer, and then U2, R, U2, R prime. So pretty simple. You recognize it by seeing that these two colors are the same. F, R prime, F prime, R, U2, R, U2, R prime. So yeah, that's the fourth case. So moving on to the fifth one. So this is the fifth case where these two colors are opposite. So it's not related to any of the previous cases so far. These two colors are opposite and these two are the same. So that's how you recognize this. Again, this is why this subset is so confusing. It's because there's such minor differences in which colors are opposite and which are the same. So you have green and blue as opposites and reds are the same. That's the way you recognize this, and the way you execute this is by doing a U. So you hold it from this angle and you do R prime, F prime, R2, U, R prime, F prime, R prime, F, R2, U prime, R prime. So let me set that up. So yeah, from this angle, again we recognize that these are opposites and these are the same. Reds are the same, green and blue are opposite. Holding it from this angle, you do r prime f prime r2 u, r prime f prime r prime f r2 u prime r prime. So yeah, a very tough case. And yeah, moving on to the last one. So this is the last case where you have opposite colors here and opposite colors here. So this is a very confusing case because it looks like a Sune, except in the Sune, these two were opposite colors and these two were opposite colors. But here, these two are opposite colors and these two are opposite colors. So red and orange are opposite, green and blue are opposite. So that's how you recognize this. And the algorithm you use for this is also quite simple. And it goes like this. You hold it from this angle. R prime f2 r u2 r u prime r prime f. So again, from this angle, these two are opposite, these two are opposite. R prime f2 r u2 r u prime r prime f. And that concludes our Sune subset and brings us to our very last subset of the CLL method, and that is the Anti-Sune subset. So let's get right into that. So the way you recognize the Anti-Sune subset is, again, you have this one yellow corner oriented, but there's no yellow corner here, as like in the Sune it was here, but here now it's here. And again, they go in a clockwise sense. So this is like this space is here, this space is here, and this space is here. So it's like a mirror of a lefty version of a Sune basically. And the thing with the Anti-Sune subset is that different cubers recognize it from different angles, and it depends on the cases. But I prefer this as my home grip as like the angle, simply because it's sort of simple. Like, you know, this is like the original Anti-Sune on a 3x3, and you do r u2 r prime u prime r u prime r prime, and that works on the 2x2 from this angle. That's why I hold it from here. So let's get right into this Anti-Sune subset. So this is the first case in the Anti-Sune subset, and if I were to explain each case as a lefty version of the Sune subset, it would be very easy to recognize, but the executions will be different. So I will just be using them for recognition. So this is the lefty version of a Sune, and here you have these two as opposite colors and these two as opposite colors, right? Red and orange are opposite, green and blue are opposite. So you can do this with the left Sune, of course. But yeah, it depends on which angle you get it from. You can choose the algorithm of your choice, but I just hold it from here and I do r u2 r prime u prime r u prime r prime. Very simple algorithm. R u2 r prime u prime r u prime r prime. So the recognition is the exact same as the Sune case, the first Sune case, except that it's mirrored to the left side. So moving on to the second case. So this is the second case in the Anti-Sune subset, and here again we have these two as opposite colors, but these two are the same colors. So this corresponds to the lefty version of our second Sune case, the second case which I showed you in the Sune subset. And for this, the algorithm you do is, actually you hold it in the back with a u2, you put it in the back, and you do r u2 r prime f r prime f prime r u prime r u prime r prime. So again, these two are opposite and these two are the same. So you do a u2, put it in the back, r u2 r prime hedge slammer f prime r prime f r prime f prime r, and then u prime, and just insert this corner r u prime r prime. So that's the second case. Moving on to the third one. So this is the third case, and this, if you look at it from this angle, these two colors are opposite and these two are just random colors. So that's how you recognize it, that these two have no correlation but these two are opposite. And this, as you guessed it, is the third. It corresponds to the lefty version of the third Sune case, which is the Nicholas, but from the left. So you can do it with L, U and R moves, or you can just use only left moves, I mean left and up moves, or you can use right and up moves, which is the easier way to do it. And the algorithm is from this angle, R prime F R F prime R U R prime. A very simple algorithm, and it's actually L prime U R U prime L U R prime, but you can just do it with only right moves by doing R prime F R F prime, which is a sledgehammer, and inserting the last corner. So moving on to our fourth case. So this is our fourth case, and this corresponds to the fourth case in the Sune subset as well. And here we have these two are the same colors and these two have no relation to each other. So it's like a Nicholas, except these two are the same colors instead of being opposite colors. That's the way you recognize it, and so the way you execute it is by holding it from the same angle as the same angle as the Sune case, but from the left side, and doing the same algorithm as well, but with the left. So the way you do it with only right moves is F prime R U R prime U2 R prime F2 R. So I apologize if I said same algorithm, I meant like a mirror. So you mirror it to the left, that's basically what you're doing. So the way you recognize again is these are the same colors and these have no relation to each other. F prime R U R prime, U2 R prime F2 R. So yeah, that's the fourth case. Moving on to the fifth one. So this is our fifth anti-Sune case, and here we see the opposite colors are here and these two are the same color. So it's the exact mirror, lefty mirror of the fifth Sune case. And here we have, opposite colors here and same colors here. You hold it from this angle and do this algorithm. R prime F2 R F prime, R prime F2 R U prime, and then sledgehammer R prime F R F prime. So again, you have opposite colors here and the same color here, not to be confused with the second case where the opposite colors were here and the same colors were here. So opposite here and same here, you do R prime F2 R F prime, R prime F2 R U prime, R prime F R F prime. Quite simple. Moving on to the last case. So this is the last anti-Sune case, and the last case for this entire series is basically a conclusion where you have these two colors as opposite and these two colors as opposite. Not to be confused with the first case of the anti-Sunes where these two were opposite and these two were opposite. So this is a mirror of the last Sune case as well, lefty mirror, and the way you execute this is from this angle you do R U2 R prime U2 and then sledgehammer R prime F R F prime. Quite simple to execute, and also recognition does take time because you have to see where the opposite colors lie. So here they're here and here. R U2 R prime U2 sledgehammer. And with that we conclude this entire series of 2x2 CLL. So I hope the series was beneficial to you. Use it more as a guide than a tutorial, because a lot of great cubers out there have come up with these algorithms after like a ton of research. So you can definitely find resources online to find your own algorithms and what suits you best. But these algorithms are trusted by a lot of decent 2x2 solvers. So I hope you enjoyed this series, and I hope you will eventually get comfortable with CLL and start seeing those sub 3s on 2x2 and get a lot better. So that's all from our end this time, and thank you so much for tuning into this entire series, and stay tuned for a lot more content on the channels, and see you, bye.